In task 10, we're now jumping into using filters to clean up the mix a bit before we jump into proper equalization, right? We'll start off with high-pass filters. With high-pass filters, remember, or really with any of these filters, apart from, let's say, the notch filters, and even with the notch filters, we have to be careful with the multi-mic'd instruments, right? So in this particular session, there are a couple of examples of that: the kick in, the kick out, the snare top, snare bottom. So the reason we bring these up, or like over here, the bass DI, bass cab, the acoustic guitar, which is again, as I mentioned before, 3 different microphones or sources picking up the same, or 3 different channels picking up the same source, right? So we have to be careful here when applying these filters, because it's the same performance, about applying the high pass filters or these EQ filters on the separate individual tracks, right? Oftentimes it's better to apply it to a subgroup that is picking up both of the signals, right? So if we look at the drawing that I have here, and this is just an example, the kick and the snare, right? What we can do is create a subgroup, a mono subgroup that each of them is going to, and then that subgroup is then routed to the drum subgroup. So this might be a little bit confusing, but if you look at the drawing that I created here, you'll notice, so kick in, kick out, it's a mono audio track, each of them. They're coming out, they're being funneled into a kick subgroup, a mono aux track, right? So into a kick subgroup, out of that mono kick subgroup into the stereo drum subgroup, out of the stereo drum subgroup into the main output to where we can actually hear things, right? So if we look at it over here, you'll notice kick sub. So notice the difference between a mono track. Look at the kick in, look at the meter, and look at the overhead, which is a stereo track, and look at the meter. It has a division between the left and the right, whereas on the mono track it's only one, right, up the center. With the kick in and the kick out, what we're doing is we're coming out of the kick sub, right? And if we look at the kick sub over here, let's find it, you'll notice that it is a mono bus, right? So that kick sub, they're being routed out of the kick sub, going into the kick subgroup, right? It's a mono subgroup as opposed to, for example, the drum subgroup, which is stereo. Kick subgroup, the kick subgroup is then being fed into the drum subgroup, right? Going into here, right? And the same thing is happening to the snares. Snare mono tracks out into the mono snare subgroup into the stereo drum subgroup, which then comes out of the main output, which is stereo also, right? So keep that in mind, which means that now we can apply these high pass filters and low pass filters to the subgroup, right? As opposed to the and I'm going to turn off these other so that you guys can only see this stuff here, right? As opposed to putting it on the individual tracks, we're putting it across the subgroup, which is picking up both of these tracks at the same time. So you're applying this high pass filter to the overall sound coming from those 2 tracks. When we're doing this exercise, what we want to do is kind of over exaggerate. So for all of these tracks, you'll notice here that we gave you a list of tracks that we want to put it on, right? We want to put HPFs across almost all the tracks, right? So we're going to put it across all these tracks, and we want you to decide where to put them. But the best way to do that is to over exaggerate the signal, right? So I'm going to bypass this one for now. And what we're going to do is I'm going to show you an example of that in a different EQ, right? So just a fresh EQ. I'm going to bypass this one. and we're going to activate the high pass section. Make sure that you are on the right here, the high pass filter, right? Not the peak. The peak looks like this. That's what the peak looks like. You don't want that. You want this one, right? So we're going to play the kick, and we're going to over exaggerate it till it sounds super thin, and then we're going to bring it back till we have a good place. This is your knee. This is how steep your filter is. So if I bring this in, you'll notice it can get very steep, right? But with these basic EQs, which aren't the best quality, they're just stock EQs. You can get a lot done with them, but the more you push the settings, the more that you can hear its inconsistencies and maybe weaknesses. So best thing to do is probably not push the knee so much, right? So keep it less steep. I would say don't go above 12 dB, right? So for the kick, because it's a more of a low-end instrument, we're going to keep it at 6, right? So we're going to keep it very wide like that. So let me back up, and then let's try it. Right, so super thin. And when we do that, right, so with the kick, you just have to be careful because it is a low-end instrument, so we don't want to take out too much of it, right? But you notice that I over-exaggerated it, and then I brought it back to its normal state, right? Or back to where I thought it could end up in a good place, right? Where it's cutting out a little bit of those sub-frequencies that don't need to be in there, but not taking out too much. You then want to bypass and activate the plugin back and forth, A/B it, to make sure that it's at the same volume, right? So you're gain matching it. So you want it to be at the same volume with the plugin and without the plugin, because you don't want to make your decisions on this based off of a volume difference, because generally we're going to go towards what's louder and like what's louder, right? But if you match the gain, then you're able to make a decision based off what the plugin is actually doing with the frequencies. Right, so I gain matched it so that it could be a little bit cleaner, and it was set right in a good place. You're going to have to critically listen with some of these, right? Some of them are going to be very subtle, so if you don't hear it, don't worry. You're just starting out. Just take your time and make sure that you get this correct, and do this same procedure for all of these tracks in here, right? So that you can get your practice on the high pass filters. The same thing you're going to do with the low pass filters, except it's now, let's say on the kick subgroup, you're now doing it on the other side, right? So you're turning this one on, you're making sure that you're on this one here, on this filter, not this filter, right? You don't want this that you can get later down here. We want it on this side, and then again, over exaggerated, go all the way in till it's very bassy, right? Or till you're taking out a lot of the high end, so it sounds very dull and muddy, and then bring it back till you like the way it sounds, right? I would say be conservative with this. Before, if you're not very comfortable with EQs, be conservative, right? So bring it in, over exaggerate it, and then bring it back to where you think it sounds good, and then push it a little bit more out beyond that, just to be safe, right? And do that. That's only 2 tracks that you have to do it on. You then jump into bandpass filters, which is it's filters that kind of limit the frequency range on both the low and the high end. So you're using both low pass filters and high pass filters to change the frequency range of a particular instrument, to limit it, and to almost change the timbre of it. And we've given you, for eGuitar 4, we've given you an an example of that, right? So I'm going to get rid of this one because I don't need it. I'm going to turn this one back on. We're going to go to E-Guitar 4. So if we look at E-Guitar 4 here, you'll see that this is what we're looking for, right? So oftentimes I'll get students that will, let's go into the bandpass or the 7-band. They'll turn on both filters and they'll leave them at 20 hertz and 20 kilohertz, and they'll turn this in as a bandpass filter. That's not necessarily a bandpass filter. Remember that a bandpass filter is about limiting it to a certain frequency range, right? And in this case, you're not really doing much, right? You're keeping it way too wide. This is even too wide. You want to bring it in a lot more, right? So you're making a decision to say, I want it to sound like this. This is where I want it to be focused in, right? And that's kind of what we did with this guitar over here. So no insert. Let me bypass this and let's listen to this E-Guitar 4. Let's see where it plays. So right here. Let's activate the EQ. So we made a decision to put it there for a particular reason because it felt like that worked well with all of the other elements, right? So when we're talking about frequency ranges, we're talking about not building up in a certain area and not stepping on the toes of another instrument, right? And sometimes doing stuff like this for certain instruments, it helps to alleviate some of that frequency buildup. But it's a choice that you're making, right? So when you're thinking about your final project, think about how these filters, how the high-pass filter, the low-pass filter, the band-pass filter can help you alleviate frequency buildup in the extremities, right? The extreme highs, the extreme lows, and about making creative decisions with maybe some bandpass filters on some instruments that maybe are taking up a lot of space in some area. But with your bandpass filters, a lot more than with the other filters, we really have to be looking at our gain matching. Look how much we're turning this up, right, to get it to be equal in volume, right, with and without the plugin. If we listen to this with and without the plugin, what we're going to hear is mainly a timbre change, but not necessarily a volume change so much. I mean, we got it pretty close. It's tough though sometimes. Right, so it's right in the ballpark, but there's not this huge jump in level when we bypass the EQ versus when the EQ is activated. So always make sure that you're gain matching your plugins. Do not wait till the end to gain match your plugins, because it will be a lot harder when you have 4 plugins on here and each plugin is affecting the next plugin in the chain, right? So you'll have to be doing double the work or triple the work. The last type of filter is your notch filters, and I give you in lesson 2, I show you exactly where that particular filter is explained, where Butch explains that particular notch filter, so that you can revisit that lesson if you're having a hard time with this. Remember that your notch filters are only to be applied to percussive elements that don't change pitch, right? So a piano is a percussive element, but it changes pitch, right? So you wouldn't apply it to something like that. You'd apply it to, for example, some of the drum tracks, or maybe you have percussion tracks in your mix session. You want to apply it to those, or to some of those too. You can, but only limit it to your percussive elements. And when we're talking about notch filters, we're talking about something like this, right? So some of the characteristics of notch filters: 1, they're on percussive elements that don't change pitch. 2, they're narrow bandwidth. Look at the bandwidth. Look how narrow these filters actually are, right? So I'm going to use this green one here that we're not using, and let's turn it down. That would not be a notch filter. You would have to make this bandwidth very narrow, and then it starts. That is what a notch filter is, because what you're doing is trying to alleviate the resonant frequencies within that particular instrument. So you're trying to be as transparent as possible. You're trying to go in there and be surgical with it and bring out those resonant frequencies that are not helping that particular instrument. So I'm going to turn this one off. And the third characteristic is that you're attenuating, right? You're turning down the resonant frequencies not gaining them and making them louder. You're bringing them down, right? So if we look at the worksheet, you'll see that we give you the mix elements that we want you to apply these particular filters to, and we actually give you the frequencies and which EQ filter to use, right? So over here, if we look at what this corresponds to, it's the low filter notch, the low mid filter notch, the mid filter notch, high mid filter notch, high filter notch, right? So that corresponds to right here, LF, LMF, MF, HMF, HF. There you go. And we're giving you the exact frequencies that you have to apply them to. What you have to decide is how much you have to turn down those particular frequencies. Now, what I recommend you do is you pull up the Blue Cat in conjunction with this exercise so that you start to become familiar with what these frequencies look like, right? So if we were to bypass this is on the kick right now, right? And we look at the signal over here. I'm going to solo the kicks, and right now this is telling us to notch out 107 hertz, 162 hertz, and 315 hertz, right? So when we come over here, we're going to play this. So this is the frequency profile of the kick, and if you look here, you'll see that this seems to be the harmonic, right? So this is the characteristic of the kick. So about 47 hertz is where the actual personality of the kick is. But then you have, the harmonics are over here, right? So they extend beyond right here, this fundamental. 47 hertz is the fundamental of the kick, and then the harmonics extend beyond it, right? So the harmonics being somewhere over here, and we're trying to trim down some of these. So if you actually look at this, you'll see that it kind of lines up with what we're looking at here. So 100, it's around 100, a little bit past 100, somewhere in the middle between 100 and 220, and then somewhere up here beyond 220, right? And if we look at what we're not telling you to notch out, it kind of matches that, right? So use your Blue Cat to figure out if that actually lines up, right? And so right now we're giving you all the answers, but when you jump over to your final mix project, you have to know how to do this on your own, right? And how to figure it out. So use your Blue Cat to your advantage and start trying to understand what the fundamental looks like, and where the harmonics could be, and which could be the problem frequencies, right? And you can listen to these. You can go in there and you know what I'm going to do? I'm going to copy this down. I'm going to bypass that one so I don't mess it up. And we can listen to these frequencies. I'm going to turn these off for now. And I'm going to turn this one up. All right? We're taking that out. So what you can do is kind of move your filters around, right? So you can create a filter kind of like this one right here. Turn this one on. I'm going to turn it up, and then you can move it around to see where those frequencies are at, the ones that sound the worst for that particular instrument. Right? So there's something around here that sounds weird. Right, and then when you find it, you go in and you so that's just an example of how to actually do that, right? But you could go in there and listen to this one too, see what it sounds like. Taking that out also, and all the way down the line. So these resonant frequencies, we've made it simple for you just because it can be hard to find these resonant frequencies within, especially when you're just starting. But as you get better, it'll become easier. And we gave you the answers so that you can understand and you can backtrack and look at the blue cat and understand properly how to see these and hear them, and then you can apply it to your final project in a free-form manner. Just remember also with the EQ, if I pull up the EQ7 band, remember that you have options on the LF and the HF to switch it to shelving, right? So the shelving filter. So if I had my shelving filter on over here and I turn this up, look what it's doing, right? So it's turning up the instruments in an equal manner, right? So if I turn off this LF, you'll see here that the shelving filter turns from the cutoff frequency, it turns up or turns down all the frequencies above that cutoff frequency with equal amplitude, right? And that's not what we're looking for. We're looking for a peak filter, right? When we're dealing with this, right? When we're dealing with notch filters, we're looking for peak filters. So you're gonna have to switch these over to peak in order for them to work properly on this particular filter. So remember, peak filters, not shelving for this task.